Today we will be doing indices of the CAT syllabus. Suppose if you have an expression like a to the power m, so here a is called the base and m is called the exponent. So literally what it means is that this particular quantity a, we are multiplying it with itself m times. Now if the exponent has a negative sign, suppose a to the power minus m, then it will be the reciprocal of a to the power m. If the exponent is 0, then the answer is always equal to 1. Any number other than 1 and 0, any number other than 0, if you raise it to the power 0, the answer will be 1. Now, if m is a fraction, in that case, for example, m is equal to a to the power 1/3, so that will be cube root of a. Suppose if m is 2/5, so that is 5th root of a square. So if m is a fraction, then we can consider the expression like this. Now, suppose let us say that you have two expressions, one is a to the power x and one is a to the power y, and they both are equal to each other, suppose. So if a is not equal to 1 and not equal to 0, or minus 1. So if a is not equal to 1 or 0 or minus 1, in that case we can say that x will be equal to y. So once again, suppose a to the power x is equal to a to the power y, provided a is neither 1 nor 0 then or minus 1, then x will be equal to y. Now suppose let us say that there are two quantities a and b, neither of them is 0, and you have been told that a to the power x is equal to a to the power y. In that case, a and b will be equal if x is odd and a will be equal to plus minus b if x is even. Once again, let us say you have a to the power x equal to b to the power x, and neither a nor b is 0, then a will be equal to b if x is odd and a will be equal to plus minus b if x is even. Now there are some laws of indices. The first law, a to the power m into a to the power n is a to the power m plus n. Second law, a to the power m by a to the power n is a to the power m minus n. A to the power minus m is 1 by a to the power m. A to the power p by q is equal to qth root of a to the power p. A to the power m whole to the power n is equal to a to the power mn. AB whole to the power m is equal to a to the power m into b to the power m. A upon b whole to the power m is a to the power m by b to the power m. A to the power 0 is always 1 except when a is 0. And on any occasion, we can always write a as a to the power 1. Sometimes when you have multiple indices, for example, if you have 2 raised to the power 3 raised to the power 2 raised to the power 2, what you have to do, you have to start from the innermost. So 2 raised to the power 2 is 4 and 3 raised to the power 4 is 81. So this expression is equal to 2 to the power 81. Now suppose, let us say that you are given 2 indices and you are asked to compare them. Suppose 2 to the power 1 by 4 and 3 to the power 1 by 5. Suppose you have to compare them. So to compare them, you consider the LCM of 4 and 5 is 20. So this will become 2 to the power 5 by 20 and 3 to the power 4 by 20. Now 2 to the power 5 is 32 and 3 to the power 4 is 81. So it's clear that this number is greater. On the other hand, suppose we are asked to compare 2 to the power 48 and 3 to the power 36. So what we can do is we can write 2 to the power 4 whole to the power 12 and 3 to the power 3 whole to the power 12. So here 12 is the HCF. So when you are comparing fractional indices, you have to take LCM, and integer indices you have to compare HCF. So you know that 2 to the power 4 is 16 and 3 to the power 3 is 27. So obviously this is greater. So that brings us to an end of this session of indices.